Wow, day 7 was really tricky compared to day 6. Today's input is simulating moving through a folder structure on a computer, navigating in and out of folders, and listing the content in each folder. A line starting with a $sign is a command. The cd command navigates the folder tree, either into a folder if followed by a folder name, or back one folder if followed by ... The ls command lists the files and folders in the folder you're currently standing in. Folder starts with the word dir, followed by the name of the folder. Files start with a number, which is the file size, followed by the name of the file. Our job is to go through the input, figure out the folder structure, and then figure out how large each folder is in size. Based on the example input, we end up with the following structure. A root directory called / containing two directories, A and B, and two files, b.txt and c.dat. The D folder at the bottom has 4 files in it. Inside the A folder, we have another folder called E and 3 files. And lastly, the E folder has a single file in it called I. The size of each folder is the sum of all the files contained anywhere inside that folder. For example, the root folder has the size of all the files combined. The task for part 1 is to find all of the directories with a total size of at most 100,000 and then get the sum of those directories. Okay, let's get to coding. My first task is to organize the folder structure. I want to represent this in an object. Each key will be the name of the file or folder, and the values will be either a number for files representing the file size, or for folders, another object with its own files and folders in it. I also want to use an array with a list of folders to keep track of where in the folder tree we currently are. Going line by line over the input data, I first want to start with the commands, so I check if the line starts with the $sign. Then I split the line on space and grab the command, which will be either cd or ls, and the folder name in case there is one. If the command is cd, I want to push the folder name to the list holding the current position, unless the folder name is ... in which case I want to pop off the last item of the array since we're moving up one folder rather than into a new one. As I move into new folders, I also need to create the folders in my structure object. I grab a piece of code from Stack Overflow to help me with this, put it in a function called createNestedObject, and call that function with my structure and current position every time I move into a new folder. Next, I want to start adding files to my folders. Since we're creating folders every time we cd into one, I'm just going to ignore any line starting with dir. For the other lines, the files, I use a similar function, write_to_nested_object, to insert the file name as key and the file size as value in the correct folder. Lastly, I was going to go through the folder structure and figure out the size of each folder, but this got tricky, so I thought of a different approach of getting the result I want. I created another structure called folder sizes, a flat object where the keys are folder names and the values are folder sizes. Then, in my write_to_nested_object function, I update the size of the folder for every folder that the file is in, based on my current position array. At this point, I'm almost done with part 1. The last thing needed is to go through the folder sizes object, find the folders that are larger than 100,000 and sum those. I finally get an answer that seemed correct, so I go to submit. But my first guess is wrong. The folder names, it turns out, are not unique across the tree. So any folder named A, no matter where it is in the tree, gets treated like the same folder in my structure. To fix this, we save the full path to the folder rather than just the name. This time we get a different output. We go to submit and it's correct. Beautiful. For part 2, we get information on the total disk space available on this imaginary machine and how much free space we need available to complete the task. Our job is then to find the smallest folder we can delete that would free up just the right amount of space. We defined some variables to help us with the numbers we're looking for and add an array called delete options. Then we loop through the folder sizes, just like before, but this time we push the size of the folder into delete options if it's larger than the size we're looking for. Lastly, we sort the delete options array, smallest to largest, and grab the first item. This should be our answer. Submit time, and we get it. Huge relief. For me, today was by far the trickiest puzzle yet. So let's see what day 8 looks like tomorrow. If you enjoyed this video, please hit the like button. That would make me really happy. Thank you for watching and have a great rest of your day.